Okay, good afternoon, ladies. You already know us, but my name is Jamie Short, and this is Rebecca Hall. We are both pre-vet majors. We know that a lot of you ladies are also science majors, so we thought it'd be a good idea to talk to you today a little bit about a course that some of you might have the opportunity to take or might be required to take, and that's organic chemistry. We're going to just basically run you through some basic structures and naming, as well as a mechanism to show you a little bit of what you might see in an organic chemistry class.
Alrighty, so we're going to show one mechanism, and so our starting structure for this is this wonderful thing right here. So basically, if you've never seen a bond line structure before, each of the lines indicates at the end there's a carbon here. So just like this is how we draw it in like shortcut terms. And then the naming of these, essentially it's cyclo at the front indicates to someone who's drawing. The bond lines that the 5 carbons involved are attached together in a ring. And then the pent part is like a pentagon, so it indicates that there's 5 carbons. And the anone at the end means that there's a double bonded oxygen, which is a ketone element to our cyclopentanone that we're starting out with.
So now what we're going to do for you ladies is we're going to walk you through a quick, simple little mechanism. And we're going to show you basically how a chemist can go from this molecule to this molecule with the addition of a couple of reagents. So we're going to start by whatever's shown above this little arrow here is going to be something that we're adding to the mix. So say we've got a cup of this molecule in solution. We're going to add, we're going to add a reagent. And so basically this negative charge, these electrons on this molecule, this is a methyl group, these electrons are going to cause an attack on this carbon that's double bonded to the oxygen. Now when this comes in, it's going to bump the double bond up onto the oxygen, creating a negative charge. So next what we're going to do is we're going to draw the intermediate. So we're still going to have an oxygen and a 5-carbon ring. But this time, in the absence of this double bond, we're now going to have a negative charge up on the oxygen with the addition of this methyl group. I'm an excellent drawer. So now we're not quite done yet because this oxygen has a negative charge. So what we're going to do is we're going to add a little bit of water to the solution. This negative charge up on the oxygen is going to come down and grab hydrogen off of this oxygen. This charge is going to bump over onto that oxygen, and the hydrogen is going to become part of an alcohol group on our carbon structure.
Perfect. And this makes the oxygen stable because it always wants to have 2 bonds. Since it lost this one, it grabs hydrogen to make up for it. And then our end result is, as you can see, another cyclopent. So it's a 5-carbon ring. And then it's an anol at the end now because that indicates an alcohol group. And it's a methyl, which indicates that the methyl and the anol at the end are on the same carbon. So it's a methyl cyclopentanol. And that's our mechanism.
Awesome. Well, thank you ladies for taking your time to listen to us. I hope that you will now see that organic chemistry is not that terrifying and you can take the class.
And you should. It's fun.